Then what is adaptive filters? See, this is a continuation of our basic knowledge on filters. Little, it is considered that you know what is basic filters. Still, in subsequent classes, I will try to go back and to give some flashback on these terms. What is filters? What is coefficients? What is FIR filter? What is IR filter? I'll try to do that. Okay, as we proceed. Today in today's class, we'll only continue with this lecture. Okay, what is already given. কি বলে সাইদ তারপরে একটু অ্যাটেন্ডেন্সটা দিয়ে দিও
জি স্যার দিয়ে দিব
Okay, see some of the filter design. When you design a filter, you need to have certain coefficients, filter coefficients. How do you define where from you get these filter coefficients? Normally, it is dependent on like second order statistics of signals, but in certain uses, like such application of channel equalization, then eco cancellation, then system modeling, where you do not have prior signal, prior coefficients of the filters, and you need to adjust the filter coefficients with the time, with the type of signal contents, and so on. And varying the filter coefficients basing on signal or with the progression of time, this varying the signal, varying the filter coefficients is somehow like getting adapted with the new situations or new signals, and thereby then this name comes adaptive filters. So in adaptive filters, we modify or update or change the filter coefficients basing on mainly our signal content. So, but this following the signal content is also not very straightforward cases. So normally we follow two algorithms. One is least mean square LMS algorithm, which is based on the gradient optimization for determining the coefficients. So least mean square algorithm is also an established algorithm, and the other one is the class of recursive least square algorithms. Recursive least square algorithms, in which both direct form FIR and lattice realizations are being used. So now, where these adaptive filters are being used, see, before going to discuss with the adaptive filters, we are discussing the applications so that we are aware of its application, and from there we get how it is important and how it is implemented. Certain background knowledge we get beforehand going into the filter itself. Okay, so see, adaptive filters have been widely used in communication systems, control systems, and various other systems in which which are the places it is used, where the statistical characteristics of the signals to be filtered are either unknown or in some cases are slowly time variant. Okay, so see, very specifically we find out the fields where these adaptive filters are used. Where are used? In systems like in communication system, in control system, and other various systems where we don't have a prior knowledge of the filter contents, and also signal statistics, and as well as the signal will vary or is varying based, with the progression of time. So these are the conditions that is non-stationary signals. Okay. So the important applications of the filters include adaptive antenna system. Adaptive antenna system, but the name itself is self-explanatory. That means the antenna elements of the antenna, there are different parameters that may be adjusted or needs to be adjusted. Certain mechanisms, that is the there is one is the approach is the adaptive filters, and where what is done, like for beam steering, for providing nulls in the beams, in the beam pattern, and also to remove the undesired interference. So remove the nulls in the beam pattern and to remove the undesired interferences or noises. We can use this adaptive filter. So adaptive filter is used in antenna system that is termed as adaptive antenna system. Then in digital communication receivers, when we say every receiver will have a signal, received signal, which will be little different from what is transmitted, because the attenuation in the process of transmission, because there will be additional noise as signal receives the receiver. So this challenge will always be there. There will be a distance between the transmitter and receiver. Whenever there is a distance, and something else will come up. What is come up? The medium through which it is passing. From there, it will get some noise, and at the same time, there will be attenuation. And basing on the type of signal, medium, there will be other problems. At the end of the receiver, what we get? We don't get the signal, exact signal, what is expected to be received. There will be some interference. So in data communication receivers, these adaptive filters will help us in providing equalization. Equalization of intersymbol interference and other channel, and also for channel identification. Okay, because there will be multiple channels, and for channel identification also this adaptive filter helps. The adaptive noise cancellation techniques. There will be receiver, and we know the signal. If we know the exact signal at the receiving end as well, and the received signal as side by side, then we can exactly understand what is the additional noise and what has to be cancelled. So by using these adaptive filters, we can estimate the noise, and we can cancel that noise, and thereby we can get the desired signal. Then system modeling. We will see an example now. See, it also helps how to model a signal from using the known one. By using a known one, we can implement a new model, new plant accordingly. See, we have two types of filters, like responses, like IIR or FIR. IIR means infinite impulse response, and FIR is the finite impulse response. So these two types filters can be used for adaptive filters, but this IIR has got more complications than FIR. and FIR has got finite zeros and implementable, and thereby FIR filters are more convenient for use as type of filter in adaptive filters. So FIR filters are normally used with finite impulse response filters. Uh, See here, we have seen one example, the direct form of FIR filters. See, we have input, we have Z transforms. So see, Z transform is also something we should know it from the previous knowledge. So I'll try to see cover this part also. What Z transform comes? I know for some of you it is new term, and some of you it is not new. Okay, so for Z in Z transform, and see there are filter coefficients Hn, H0, H1, H2, H3, 4, and so on. It is Hn. This is filter adjustable filter coefficients. Where from this adjustable feature comes, we have seen input, and we also have output. From the output, we will have some feedback, and from this feedback we there will be algorithms in this coefficient adjustment mechanism, where we will introduce how much corrections are needed in the filter coefficients H0, H1, H2, H3, and H4, and so on. So this is the direct form of adaptive FIR filters. Okay, because we are directly updating or correcting or adapting the filter coefficients. An important consideration in the use of adaptive filter is the criteria of optimizing the adjustable parameters. But what happens? The criteria must not only provide a meaningful measure of filter performance, but it also result in a practically realizable algorithm. So if we only consider that we adjust the filter coefficients, that is not the only thing should be considered. At times we have to think how easily the filter the algorithm or adaptive filter algorithm can be adjusted. Here comes certain criteria. What criteria has to be fulfilled? What is the optimization criteria that we expect from a filter? For example, we have like average probability error. So in communication system, this expected or estimated probability error is one of the criteria which is to be taken into consideration. But this adaptive filter may not be always practical, because the highly nonlinear function of the filter coefficients and signal statistics. So at times it is desirable, but while implementing, you are going to implement the algorithm, this may not be practical. It's complex and impractical. In certain cases, like the performance index is a nonlinear function of the filter parameters. Such cases like the average probability error of a signal, digital signal communication, that must be rejected on the grounds that they are impractical and impractical to implement. That means when signal parameters are not very predictable, then you cannot depend on that parameter. One is nonlinear function of the filter parameters and the performance of the system. Two things, like one is performance of the performance index. Performance index is the error rate, for example, and your nonlinear function of the filter coefficient. They are not, may not be related directly. They may not have direct correlation. At that time, it is very difficult to implement such criteria. So that to considering all those practical problems, we use two criteria. One is MSC, that means mean square error. The other is the least square criteria. So these two criteria normally practicable and can be implemented. Now we are giving one we are going to discuss one example where which is the system identification or system modeling. Okay, so how we can understand this a system by using another known system. Okay, like I have a system, I do not know what is the condition of its, what is the value of its coefficients. So what I can do, I can place a known similar plant side by side, and we can update the known one, and thereby we know the one which is not known to us. I mean, abar bolchi, like what is system identification or system modeling? Where what is done here? Like I have a system which I know its parameters, whose filter coefficients are known to me, and I have another system where I do not know the filter coefficients or its responses. Okay, now what I'll do, I'll set, in this example, I will set these two systems side by side, and I will try to see where the outputs, how the outputs are. knownটা এবং unknownটা আমি দুই রেজাল্টটা কম্পেয়ার করব। কম্পেয়ার করা মানে বিয়োগ করা। বিয়োগ করে যদি রেজাল্ট পাই তার মানে there is something, দুইটা নাই। যদি দুইটারই আউটপুট সমান হয় তাহলে বুঝবো যে না দুইটার একই রকম আউটপুট। আমি যেটা জানি সেটার ভ্যালু দিয়ে আমি ওটা বলবো ওটার ভ্যালুটা ওইরকম। আচ্ছা, সো হোয়াট আই ডু, যদি দেখি যে দুইটা সিস্টেমের নোন আর আননোন সিস্টেম, দুইটার সিস্টেমের আউটপুটে একরকম হচ্ছে না, তো আমি কি করব, নোন সিস্টেমের প্যারামিটারটা চেঞ্জ করব। করতে করতে এমন একটা অবস্থায় নিয়ে আসবো যেখানে আননোনটার এবং নোনটার আউটপুট একরকম হবে। সো আমি তো জানি যেটা আমি চেঞ্জ করলাম, নোন প্ল্যান্টের নাম হলো মডেল, নোন প্ল্যান্টের আমি ফিল্টার কোএফিশিয়েন্ট চেঞ্জ করে আমি একটা অবস্থা নিয়ে আসলাম। সো আই নো এই অবস্থায় দুইটা আউটপুট সমান। সো দ্যাট মিনস ওটার আউটপুটটা, ওটার ইম্পালস রেসপন্সটা বা ওটার ফিল্টার কোএফিশিয়েন্ট গুলো, নাও আই ক্যান কম্পেয়ার like this, that's why the output সমান। সো একটা নোন দিয়ে আরেকটা আননোন কে জানা, এটাই হলো সেই সিস্টেম আইডেন্টিফিকেশন। where is the use of this adaptive filter? Because যেটা আমি আমার কাছে জানা আছে সেটার ফিল্টার কোএফিশিয়েন্ট গুলো আমি ভ্যারি করতে পারছি, এটাই হলো অ্যাডাপ্টেশন, এটাই হলো অ্যাডাপটিভ ফিল্টার অ্যাপ্লিকেশন পার্টটা এখানে। So what is done here, see, we have an unknown time variant system. We say this is plant, the top one, and second one, that means this one, this is plant, and this is model. Okay, this is model, is known one. Now we give here input, same input in two systems, and both systems are supposed to get the same output. Here yn, here y caret n, and if both outputs are same, এই সিস্টেম এবং এই সিস্টেমের যদি ফিল্টার কোএফিসিয়েন্ট গুলো একই রকম হতো তাহলে দুইটার আউটপুট একই হতো, এবং আউটপুট একই হলে এই এরর সিগন্যালটা 0 হয়ে যেত। আচ্ছা, এখন যদি এক না হয়, যদি এরর সিগন্যাল থাকে, আমি কি করব? এটার ফিল্টার কোএফিসিয়েন্ট আমি চেঞ্জ করতে থাকবো, বাড়াতে থাকবো বা কমাতে থাকবো, যাই করে একটা করবো। করার ফলে বাড়াবো বা কমাবো কিছু উপর নির্ভর করবো এই সিগন্যালটার রেজাল্টটা কি হচ্ছে, কেমন হচ্ছে, এটা পজিটিভ সিগন্যাল পাচ্ছি এরর সিগন্যাল নাকি নেগেটিভ এরর সিগন্যাল পাচ্ছি, তার উপর নির্ভর করে আমি ফিল্টার কোএফিসিয়েন্ট গুলো বাড়াবো বা কমাবো। বাড়ানো এবং কমানোর পরে একটা স্টেজে এসে দেখা যাবে যে দুইটার আউটপুট yn এবং y caret n is same, is equal, and thereby error signal is 0. At that time I know the coefficients of this model, so thereby I can say what is the filter coefficients of this unknown filter prince, এটার ইম্পালস রেসপন্সটা কি সেটা আমি বুঝতে পারবো। সো এটার ইম্পালস রেসপন্স এবং এটার ইম্পালস রেসপন্সটা দুইটারই রেসপন্সটা একই রকম হবে। সো এটারটা যখন আমি ভ্যালুটা জানবো, সো এই আননোন যেটা সেটারটা আমি প্রেডিক্ট করতে পারবো হোয়াট ইজ দ্য হোয়াট ইজ ইটস ভ্যালুজ আর। এখানে কি করলো আমাদের y caret n, এটা ইকুয়াল টু hk into x n minus k. So you understand এটা হলো একটা সিস্টেম এর আউটপুট বের করার জন্য এটা এই h কেটা হলো এই সিস্টেমের ইম্পালস রেসপন্স, আর x n k এটা হলো আমাদের সিগন্যালটা। সো দিস ইজ দ্য আউটপুট y caret n. সো এই যে এরর সিগন্যালটা হবে এইখানে যে এরর সিগন্যালটা en এর ভ্যালু কি হবে yn minus y caret n। আমাদের এইম থাকবে টু গেট দিস এরর সিগন্যাল মিনিমাম। সো hn কে টু মিনিমাইজ কিভাবে মিনিমাইজ করতে পারবো, আমাদের en m হলো আমাদের টু মিনিমাম এরর ইকুয়াল টু yn minus y caret n। y caret n এর পরিবর্তে এই ভ্যালুটা বসালাম, এখানে বসায় এটাকে স্কয়ার করলাম, করে আমাদের টার্গেট হলো টু গেট দ্য মিনিমাম ভ্যালু। And when we get the minimum error value, at that time we can reach a condition যেখানে আমাদের যখন মিনিমাম ভ্যালু হবে তখনই আমরা এই কন্ডিশনে পৌঁছাবো কি আমাদের সামেশন k equal to 0 to m minus 1 h k r x x l minus k equal to r y x l। এই r হলো আমাদের কোরিলেশন, আর x x হলো অটো কোরিলেশন, আর y x হলো ক্রস কোরিলেশন। সো যখন আমাদের এই দুইটার ভ্যালুটা সমান হবে, যেখানে l equal to 0 থেকে m minus 1, তখনই আমাদের উইল গেট দ্য মিনিমাম পসিবল এরর। সো এই কন্ডিশন যখন আমরা ফুলফিল করব, সে এই RXS is the auto correlation between the signal sequences, and RYX is the cross correlation between the input and output of the signals. So by using this relation we can get the signal the filter coefficients, and thereby we can update the filter coefficients to get the required signal, and that's why it is termed as adaptive filter. Okay. Then we can also use this adaptive filter for channel equalization. What is channel equalization? Equalization, who knows what is equalization? Hello. Hello.
Sir.
What is equalization? দেখি আমি একটু দেখি তো।
Side.
Roll number 48 about the signal and it will be compared with the reference signal, and an output a feedback will come here, and it will create the error signal. Basing on this error signal, the adaptive algorithm that will induce some change in the adaptive equalizer. So this is the mechanism of adaptive equalizer part. Okay. Okay. Follow Maruf Hassan. Rule 50.
Assalamu alaikum, sir.
Follow.
নামাজের জন্য স্যার একটু ব্রেক দিলে ভালো হতো স্যার।
আমাদের ক্লাস সময় কতক্ষণ আছে আর? 5, 6 আছে না? Okay, we'll take a break of 15 minutes around. Okay. So adaptive filter will continue after break. Now is 4:30. We'll আমাদের সময় কখন আছে? 5টা 6টা তো সময় আছে অনেকক্ষণ, অসুবিধা নেই, আমরা আজকে একটু ডিসকাস করবো আরো। So 4:30 and in your time is 5 না? 5টা বাজে, 5টা 15 আমরা শুরু করবো নেক্সট। ওকে, আল্লাহ হাফেজ।
শুনতে পাচ্ছি।
Okay. So we have been talking about adaptive channel equalization. So here we see this system where the signal AN is transmitted through this transmitter, and then channel passed through this channel, and there will be some additional noise, and then the receiving end we have the receiver. Okay, and after this sampler we are supposed to get the exact signal, but we need to do some equalization. That is the adaptive equalizer is used, then we get actual input output here. This should have been the actual output, but we do further processing a caret n, and then decision device decides whether we are receiving the correct signal or not. Then we get final a caret n. So the same, if the same signal is expected signals, and nothing, no change is done. And this a caret n final output is compared with some reference signal. Okay, and then we get some error signal. This error signal is passed through an adaptive algorithm. This output of this adaptive algorithm changes the adaptive equalizer. Okay, and thereby we get this adaptive equalizer does the actual correction in the signal, and that is expected. So this is the loop we are doing. Now our input signal is AN, and we get the in this transmitter. This is also filter. So the output of the filter will be like this: ST equal to AK and PT minus KTS. So what is this PT? PT is the impulse response of the signal, and AK is the the input signal. Okay, then this KTS. What this TS means? TS means the interval. The interval. What is the interval of the period of the time? Period of the signal. Then that means this is the 1/TS is the inter-symbol rate. Then AN is the maybe multi-level signals, so we can consider in that way. Now see, this PTN is designed in such a way as shown here. See PTN. See it when t equal to 0, it has maximum amplitude, and when t equal to +1 or -1, n the value of n equal to when nts, and when n equal to +-1, +-2, and so on. That means at this point and this point, at 2ts -2ts, 3ts -3ts, at all those points, the value of the amplitude of the pulse shape is 0. And thereby, at this time, another symbol, this signal, the channel is ready, so that another symbol can be accommodated at that time. Okay, so this is the rather pulse shape. We say sometimes we get this pulse shape. Sometimes we say in this case we say the impulse response of the transmitter. So see, at t equal to 0 we have the maximum amplitude, and t equal to +1 -1 +2 -2 +3 -3. At those instant the signal strength signal level is 0. So what happens due to channel channel problem or channel distortion and some addition of noise, the output of the signal comes like this. Like, see, at 0.5 it has got the maximum amplitude, but at t equal to +1 and it is near to 0 but not 0, but at minus ts it is not 0 at all. See, huge signal. Okay, that means it has changed from the original pulse shape. It has occupied other channel spaces. Now, how to correct it? How to get the exact value? At this point, it will have maximum value, and here it is having some noise. It is understood. See, it is supposed to be 0 at minus ts, and also at plus ts, but it's not 0. So this variation is termed as intersymbol interference, and that is expected not to be there. And the systems are designed so that it can be removed. Now, see, the receiver end, receiving after the correction, we get the signal x nts. It should have been equal to a k q nts minus k ts, then w nts. This is the channel noise, additional noise. Okay, nts noise. And if you further, if you remove the further like an and q0, this is separated one, then a rest part can be considered as the noise part. Okay, this whole part is the unexpected, but only this part is the expected part. Then we can simplify the right hand side like xn equal to an plus this term. This whole term is considered to be a simplified way, and this is the term. And here we have to if this is 0, see, this is only expected signal. But if this is 0, we can reduce it to 0, and then we get we can remove it, and we get the exact signal xn equal to an. We have to remove this one. So for removing this, we have to update the receiving filter coefficients. That means equalization part. So it is যে ভ্যালুটা যা থাকবে, যদি প্লাস ভ্যালু থাকে এটা নেগেটিভ করতে হবে, নেগেটিভ ভ্যালু থাকলে এটা পজিটিভ করতে হবে, সো দ্যাট it comes 0. এই পার্টটাকে 0 করতে হবে। এই পার্টটাকে 0 করার জন্য we have to find out this condition. Okay, an equal to this the hk and xn plus d minus k. D is the channel nominal delay. There will be some delay, so channel nominal delay is also calculated, and also we have to find out, see, minimum possible error থাকতে হবে আমাদের কোথায়, এখানে error signal has to be minimum. So error signalটা মিনিমাম করার জন্য যে কন্ডিশনটা, সেই কন্ডিশনে আমাদেরকে আসতে হবে এখানে। The minimum error should be dn minus a caret n and whole square. This term has to be the minimum one to reach the desired condition. And for this we have to find out the solve this correlation value. That means hk rxx L minus k equal to r dx ln minus. That means the autocorrelation and cross correlation values that has to be using that relation the condition has to be fulfilled, and only then we get the desired equalization at the receiver. So we have discussed this in this chapter. We have discussed only two items, mainly two subsections only. What is so here in adaptive filter, we discussed what is adaptive filter and why it is important, what is the challenges of adaptive filter. Then we have also discussed two of its applications, okay, in modeling a system and also in channel equalization, how it is used. Up to this, any question? Okay. রেকর্ডিং তো বন্ধ রাখতে পারো এখন নাকি শেষ তো?